Well, this is John Black, super chemist, polarizers fundamentals, and the three polarizer paradox.
This is exactly how antennas work, with the percentages and the ratios and etc. Nobody bats an eye.
How does that work? Remember, that number 50 is coming from the case where the photon was just never measured at B. And all we're doing here is asking what would have happened if it was measured at B.
They're always with this measurement. No one gives a... They think that they're megalomaniacs. They think they're God. They think if they measure something that the universe gives a crap about them. Okay, the universe doesn't give a crap about you, your measurements, your perceptions. Okay, it's going to do what it does.
Assuming that it has some kind of definite state even when we don't make that measurement. And this is what gives us a numerical contradiction. For comparison...
See, it's always got to be, like, if we don't measure it, yeah, if you don't measure it, then it ain't rotated. It's not that you measured it, it's that you rotated it, you idiot. This is exactly what they do with the double slit experiment. They block off one of these slits so that it is a single slit experiment, right? And so you'll get a different interference pattern. And then they act confused. Like, you literally told me that you blocked off one of the slits, right? And then you tell me, literally, the very next sentence, we didn't do anything to it or anything. And all of a sudden, the interference pattern changes from a double slit to a single slit. It's amazing. And all we did was we put a detector in. Of course, our detector literally shut down one of the slits. Yeah, but we don't know what's going on here.
And think of any other non-quantum questions that you might ask. Like, take 100 people and ask them if they like minute physics, if they have a beard, and if they wear glasses. Well, obviously everyone likes minute physics, but then among those, take the number that don't have a beard, plus the number who do have a beard but not glasses. Now that should be greater than or equal to the number who don't have glasses. One is just a superset of the other.
Notice how he didn't... See, if he was being, normal and not disingenuous, right? One of these people, like these people that have beards, that they make it through one filter, but he should be shaving some of the beards off, right? So that they can get through the next filter, just like the real filters work, right? But he isn't changing anything here, right? When you do the middle filter on the filters, you are rotating it, so you're changing it. It's like shaving some of the beards off so that they can get through the third filter. But he ain't shaving no one's beards off. He ain't taking no one's, people that have glasses, he ain't just taking some of them off once they get through the filter, right? No, he doesn't. He doesn't change anything at all. This is so, like when they compare an electron to a baseball. Baseball is not vibrating. I mean, it is vibrating, but the vibration is like a Planck length. So you might as well say it's not vibrating. So to compare a baseball to an electron is disingenuous. It's retarded. You're an idiot. Okay. And then say, oh, since it doesn't act like a baseball, it must be some kind of magic. Oh, it must be leprechauns.
But as absurdly reasonable as this is, some questions about
absurd. It isn't reasonable because you didn't shave any of the beards off so that they can get through the next filter, you moron, like you do when you put in a middle filter. And when you put the middle filter in, you change things. You rotate them.
Quantum states seem to violate that inequality, which contradicts the premise that these questions could have definite answers.
They could if you weren't human. You could see down and see the oscillation of the B field on both the polarizer and the photon. Okay, why can't you just accept that? You're not God.
Even when the measurements are not made, right?
Well, unfortunately, there's a hole in that argument. Drawing those Venn diagrams assumes that the answer to each question is static and unchanging. But what?
Hey, he's got the little photon. He's got the little B field basically, asking, should I go into A, B, or C? Well, it depends. See, he answers. He knows all the answers, but he all the facts. He doesn't put them together though. Did you just hear what he just said? If somehow this first filter affected the photon when it came out, and that way it acts different to the second. Of course it rotates it. He knows that it goes. He knows it rotates it, and then he's sitting here saying, "Gee, if only we knew if it actually did anything to the photons when it went through. Yes, it does. You know it does. You know it rotates it. You know it. This one makes it go vertical. This one looks like 22 and a half. This one looks like 45 degrees. I keep thinking humans can't be any dumber. And then they just get dumber and dumber, man. Now listen, he literally draws pictures of the B field, basically. Obviously it's the E field what he's drawing, but the B field goes along with it. You know what I mean? You ain't gonna have one without the other with a photon. So I know he's just a stupid moron idiot, but this is like he knows and he's just spitting in my face, like he's telling me. He's drawing pictures. Every time he talks about how you can't know it, he draws a picture of the thing that tells you, that you would know, which is the B field.
To each question is static and unchanging. But what if the act of passing through one filter changes how the photon will later interact with other filters? So we haven't proved hidden variable theories are impossible, just that any hidden variable theory would have to have the interaction between the particle and one filter affect the interaction of the particle with other filters.
He gets rotated, and that affects how he interacts with B. Because he could be rotated to a 90 degree, he can be rotated vertical, he can be rotated yeah. Wait, is he retarded?
We can, however, rig up an experiment where the interactions cannot affect each other without faster-than-light communication, but where the same impossible numerical weirdness persists. The key is to make photons pass not through filters at different points in time, but at different points in space at the same time. And for this, you need entanglement. For this video, what we'll mean when we say two photons are entangled is that if you were to pass each one of them through filters oriented the same way, either both pass through or both get blocked. That is,
they're not entangled. They're just Jesus Christ! This is like up and down in a Stern-Gerlach machine. You oriented both photons to be vertical. Okay, that doesn't make them entangled. Okay, it just makes them have the same plane. Plane of wave plane. That's all.
Behave the same way when measured along the same axis. And this correlated behavior persists no matter how far away the photons and filters are from each other.
Yeah, because you oriented them both to be vertical, and then you're like, oh, they act pretty similar to when we separate them. Yeah, of course they do. If I make two quarters and I have them both, force them to be heads up, and then I take them to another, we split the quarters up, and then I call one guy that has the other quarter. I'm like, hey, I want you to flip your quarter over. And I'll flip my quarter over. Oh, what do you have, a tails? Oh, I got a tails too. Oh, wow, we're quantum entangled. Freaking idiots.
Even if there's no way for one photon to influence the other, unless somehow it did so faster than the speed of light. But that would be crazy.
So now here's what you do for the entangled version of our photon filter experiment.
Through or both get blocked. That is, they behave the same way when measured along the same axis. And this correlated behavior persists no matter how far away the photons and filters are from each other, even if there's no way for one photon to influence the other, unless somehow it did so faster than the speed of light. But that would be crazy.
So now here's what you do for the entangled version of our photon filter experiment. Instead of sending one photon through multiple polarizing filters, you'll send entangled pairs of photons to two faraway locations and simultaneously.
Remember, they're not entangled. They're just reoriented, both of them, to be vertical, or to be in the same, have the same plane, wave plane.
Simultaneously, at each one of those locations, randomly choose a filter to put in the path of the photon. Doing this many times, you'll collect a lot of data about how often both photons in an entangled pair pass through the different combinations of filters.
But the thing is, you still see all the same numbers as before. When you use filter A at one site and filter B at the other, among all those photons that pass through filter A, about 15% have an entangled partner that gets blocked at B. Likewise, if they're set to B and C, about 15% of those that do pass through B have an entangled partner that gets blocked by C. And with settings A and C, half of those that get through A get blocked at C.
Again, if you think carefully about these numbers, they seem to contradict the idea that there can be some hidden variable determining the photon states. Here.
This is so disgusting. And it's not even about stupidity. I call them stupid and this and that. It's about, they want magic to be involved. And if they can't get that magic, they'll lie to get it. You know what I mean? That's what it's all about, really.
Venn diagrams that we had before, which is to assume that each photon actually does have some definite answers to the questions, would it pass through A, would it pass through B, and would it pass through C? If, as Henry said, 15% of those that pass through A get blocked at B, we should nudge these circles a bit so that only 15% of the area of this circle A is outside circle B. Likewise, based on the data from entangled pairs measured at B and C, only 15% of the photons passing through B would get blocked at C. So this region here inside B and outside C needs to be sufficiently small. But that really limits the number of photons that would pass through A and get blocked by C. Why? Well, look, this region representing photons passing A and blocked at C is entirely contained inside the previous two. And yet, what quantum mechanics predicts and what these entanglement experiments...
Quantum entanglement does not predict this, okay? The math predicts it, you idiot. Everyone has the same damn math. They always claim it like, oh, this is quantum physics. Classic physics don't believe in this. You're a moron, okay? You're using a statistic probability freaking equation, you moron.
verify is that a full 50% of those measured to pass through A should have an entangled partner getting blocked at C. If you assume that all these circles have the same size, which means any previously unmeasured photon has no preference for one of these filters over the others, there is literally no way to accurately represent all three of these proportions in a diagram like this. So
that's because you're lying with your diagram. You're not showing the rotation that you put, that these middle filters in the first filter put on these photons, are you? You're not putting that. I don't see that in your equation here, you dumb piece of garbage.
It's not looking good for hidden variable theories.
So again, for a hidden variable theory to survive, these results can...
I love how every time he's saying, oh, we just don't know what it is, some kind of hidden variable, and then he draws a freaking a B field. What an idiot.
Only be explained if the photons are able to influence each other based on which filters they pass through.
No.
But now we have a much stronger result, because in the
it can only be explained by magic, because I'm a freaking idiot. What a moron.
case of entangled photons, this influence would have to be faster than light. The assumption that there is some deeper underlying state to a particle, even if it's not being probed, is called realism. And the assumption that faster than light influence is not possible is called locality. What this experiment shows is that either realism is not how the universe works, or locality is not how the universe...
No, all it showed is that you're a stupid moron, that you can't see the most obvious crap, and 2 plus 2, you're like, oh, it's 5, I think.
works, or some combination, whatever that means. Specifically, it's not that quantum entanglement appears to violate realism or the speed of light while actually being locally real at some underlying level. The contradictions in this experiment show it can't be locally real, period.
What we've described here is one example of what's called a Bell inequality. It's a simple counting relationship that must be obeyed by any set of questions with definite answers, but which quantum states seem to disobey. In fact, the math of quantum theory predicts that entangled quantum states should violate Bell inequalities in exactly this way. John Bell...
Yeah, the B field oscillates, so your percentage probability should oscillate too. That's why it's 185.50 instead of 175.50, because it's oscillating. And if you went all the way down to the whole 180 degrees, it would have went down and up, down and up, down and up, down and up, because it's oscillating. Idiot.
Bell originally put out the inequalities and the observation that quantum mechanics would violate them in 1964.
Since then, numerous experiments have put it into practice, but it turns out it's quite difficult to get all your entangled particles and detectors to behave just right, which can mean observed violations of this inequality might end up with certain loopholes that might leave room for locality and realism to both be true. But the first loophole-free test happened in 2015.
There have also been numerous theoretical developments.
Let's go over what quantum entanglement is. This is the big... I don't... Like, do these people just crap on themselves and go out in public? They don't care. They have no pride, no honor. No honor. None. No shame. When you're entangled, that means both photons are oriented vertically. They're vertically oriented, okay? And if they put it through the same axis, right? They put them both through here with the same vertical thing, they'd go through. And here they would not get through. Both of them would not get through. But we already know if they're both vertically oriented, obviously this is going to happen. It's not magic. It has nothing to do with quantum entanglement. So then he says, oh, they do it now. They're going to do it far away.